All right, class, welcome back. We are in section 9.1, and this is the second part of the lesson. First video part of the lesson was about simplifying radicals, and so now we're going to talk about the Pythagorean theorem, and then we'll apply that throughout the process. First, I'm sure you've learned about this before. You probably learned about it in middle school, talked about it a lot. The Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle are equal to the square of the length of the hypotenuse. That is extremely wordy. Don't stress about trying to memorize that or anything. But what we need to be able to do is simply identify the legs of a right triangle. The legs are the sides that are adjacent to the right angle. So our legs are A and B. And then identify the hypotenuse. The hypotenuse is the side that's across from that right angle. In this case, it's C. So if I square each leg, A squared plus B squared, and add them together, then I get the length of the hypotenuse squared. So we'll apply this in a couple different examples. You will prove this in your groups on another sheet of paper. So first, the application. All right, so first thing we want to do is identify what the hypotenuse is. Easiest way, draw a little arrow shooting out of that right angle. That's going to be my hypotenuse. So when I set up the Pythagorean theorem, it doesn't matter which one I call A or B in terms of which leg. Just make sure that C is your hypotenuse. So the Pythagorean theorem says that A squared plus B squared is equal to C squared. So I'll plug into that, substitute, and I get 5 squared plus 12 squared is equal to x squared. Now I'll just evaluate it, and I get 25 plus 144 is equal to x squared. So that means 169 is x squared. However, I want to know what x is, not x squared, so I'll take the square root of both sides, and x will give me 13. Remember, because x represents the side length, we can disregard the fact that x, in solving this equation, would truly be plus or minus 13, but because x represents the hypotenuse length, it has to be the positive, so x is 13. All right, over here, we're going to start the same way. We identify our hypotenuse by drawing that arrow out of the right angle. That's going to be my C. A and B are irrelevant as long as they're both the legs. All right, doesn't matter which leg is A and which is B. So the Pythagorean theorem says A squared, so 3 squared, plus B squared, so x squared, is equal to 6 squared. Then we evaluate, and we get 9 plus x squared is equal to 36. And this time we're solving for a leg, so we need to do a little bit of algebra to get that x squared by itself. We'll subtract 9 from both sides, and I get that x squared is equal to 27. To get x, I'm just going to square root both sides, and I get x is root 27. Now, root 27 is not a perfect square. However, I need to simplify this, and I totally can. Because remember, to simplify a radical, you cannot have a perfect square factor underneath that radical sign. And 27 does have a perfect square factor. In fact, it's 9 times 3. And the square root of 9 is 3, and that leaves that 3 inside. So 3 root 3 is what x is equal to, or the length of the leg of this right triangle. Okay, so in this case, we have an application problem. This one comes up quite a bit, so pay real close attention to the specific auxiliary line that I draw here. That'll help you when you're doing this problem down the road. So first thing I'm going to do is I recognize it's a trapezoid, right? And I'm trying to find this side x here. However, I don't really know how to solve for it because we haven't really learned how to solve for a missing side of a trapezoid. But if I draw an auxiliary line, and the one I'm going to draw is this one here, and what that allows me to do is it divides this trapezoid into a rectangle and a right triangle. And what we learned about rectangles back in chapter 5 is that a rectangle is a parallelogram. And we know about parallelograms that the opposite sides are congruent. So if this is 4, this is 4, if this is 2, this part is 2. The entire length of this side was 5. So 5 minus 2 leaves 3. So how this trapezoid relates to the Pythagorean theorem is that this is a right triangle. So now I've isolated this, and I've got an application of the Pythagorean theorem. So we'll just set it up. Same deal as last time. Identify the hypotenuse. And then this will be C, A, and B. We say A squared plus B squared is equal to C squared. And we just evaluate. That gives me 16 plus 9 is C squared. So 25 is C squared. And that gives me that C, when we square root both sides, is 5. Booyah. So once you get the right triangle, very easy. The most important thing is just how you draw that auxiliary line. Biggest common mistake that I see students make is they draw this weird looking auxiliary line and this jams them up. Let's see, how did they do that in the past? They did something like this, right? Because if that's 2 and that's 4, yeah, you can figure out what this is by using the Pythagorean theorem, but now you're stuck with this kind of random triangle here, and we don't know any relationships about those side lengths. So don't do that. We're looking for a rectangle and a right triangle. All right, here we go. And the last example of these notes is, in this case, we'd like to find the diagonal, or the length of that diagonal, from one corner of this rectangular prism to the other. Right? So the reason this is an application of the Pythagorean theorem is because I'm going to take a look at the right triangle that exists inside of this prism. There's a right triangle that exists inside of the prism, and this leg's length would be 12, and let's call this leg's length A. I don't know what that is, but I do know that X here would be my hypotenuse. So what I'm looking at is I'm looking at this right triangle that exists within my prism. So let's take a look at that. Right now, if I isolate that right triangle, I don't know A. I know that this leg is 12, and I know what I'm trying to solve for. That hypotenuse is X. So now what we're going to do is we're going to take a look and kind of focus on the bottom of this rectangular prism. You'll notice that A is the diagonal of that rectangular base. So when I focus on the base itself, I know that the diagonal here has that length of A, and it's a rectangle, so it has right angles, right? And I know that this leg is 4, and this is 3. So now I'm going to use the Pythagorean theorem in this right triangle to try to figure out what A is. So really, in this problem, I'm using the Pythagorean theorem twice. So 3 squared plus 4 squared is equal to A squared. That gives me 9 plus 16 is A squared. So 25 is A squared. That gives me that A is 5 when I take the square root. Now I can take that, I can plug that in over here, and I can set up a new Pythagorean theorem for that triangle. I'll do it over here on the right. So for that right triangle down there, I got A squared, which we know was 5. So we'll plug that in a second, plus B squared equals C squared. So A, we determined, was 5. B is the other leg here, is 12. And then C is my hypotenuse, which is X. So A squared plus B squared equals C squared. So that gives me 25 plus 144 equals X squared. That's 169 is equal to X squared. So when I square root, X is equal to 13. Now, there is a shortcut for this problem that I want to point out to you, okay? So check this out. In my original equation here, I said that A squared plus B squared is equal to C squared. So A squared plus B was 12, and C squared, C, was X. But look where A squared came from, right here. A squared was simply 3 squared plus 4 squared. So if I plug that in for A squared, I can say that A squared was 3 squared plus 4 squared plus 12 squared is X squared. What you'll notice right now is all I've got here is I've got all the original dimensions of my prism. 3 squared plus 4 squared plus 12 squared equals the length of that diagonal squared. So when I evaluate that, I get 9 plus 16 plus 144 is equal to x squared, which gives me 169 is equal to x squared, and I get x is 13. What we notice, the shortcut is simply this. If I give you a prism and I ask you to find the length of the diagonal, I know it's not my best drawing there, from one corner to the other corner, there's a shortcut. And that shortcut is simply take all of those dimensions, square them, add them up, and the sum of those squares must equal the square of the diagonal. I call this, my friends, the super Pythagorean theorem. You could totally do it the way I did it originally and do it the Pythagorean theorem twice. However, you'll notice this is substantially faster. If you memorize that, it'll make your life a little bit easier. All right? So get to work on your assignments. I hope that made sense, and then come and see me if you need help.